Sometimes metaphors can show real measurable differences in terms of behavior. A great study by Kempton, 1986, investigated the real-world consequences of a metaphor. He used the example of residential thermostats, which is a temperature-sensitive controller for home heating and cooling. He reasoned that home heating systems are relatively simple and are familiar to most people living in a climate with a distinct summer and winter. Even if you don't own your own home right now, if you live in the US, Canada, much of the UK, or EU, you probably grew up in a home with a thermostat that could be used to adjust the temperature. If you live in an apartment or a university residence hall, you may also have a thermostat that allows you to control the temperature of the room. Kempton pointed out that many people must have some understanding of how the thermostat works because they typically have to adjust them several times a day or at least several times a week. This excludes the current versions of thermostats, which are highly programmable, or the so-called smart thermostats, which eventually learn to adjust home temperature automatically. Kempton argued that there are broadly defined metaphors or folk theories for how the thermostat works. He referred to one of these folk theories as the feedback theory, which suggests that the thermostat senses the temperature and turns the furnace on or off to maintain that set temperature. He referred to the other folk theory as the valve theory, which holds that the thermostat actually controls the amount of heat coming out, like a valve. A higher setting releases higher heat. Only one of these theories is correct, the feedback theory, but Kempton observed that both of these theories were present, sometimes within the same household, and that these theories had an effect on actual thermostat adjustment behavior. People who seemed to rely on the valve theory tended to make more adjustments in general and also more extreme adjustments than people who relied on the feedback theory. More adjustments translate to higher energy use. In other words, a misunderstanding of how the thermostat works, having the wrong metaphor or analogy for how it works, can have measurable differences in terms of behavior and energy use. Universal cognitive metaphors. Others have suggested that across many languages and cultures, there seem to exist universal cognitive metaphors. In many cases, these reflect a conceptual similarity between a physical thing and a psychological concept. For example, there are many metaphors that relate to the idea of happiness being up. People can be said to be upbeat or feeling down if they are not happy. Music can be up-tempo, a smile is up, a frown is down. All of these idioms and statements come from this same metaphor. Other examples reflect the idea that consciousness is up. You wake up, you go down for a nap, etc. Another common metaphor is that control is like being above something. You can be on top of the situation. You are in charge of people who work under you. The Rolling Stones recorded a popular song called Under My Thumb. These cognitive metaphors are common in English, but they are common in many other languages as well. This suggests that there is a universality to these metaphors and a commonality among cultures between language and thought. One possible explanation for the universality of these metaphors is that they are all tied to a physical state of being. The notion of consciousness being up relates easily to the notion of standing up when you are awake. If you overpower someone in a physical confrontation, you may find yourself literally on top of them. You may also have to hold the other person down. This physiological connection between being on top and being in power helps to explain why these kinds of metaphors are universal and not tied to a specific language. Linguistic relativity and linguistic determinism. The discussions above illustrate many of the ways in which language influences how you remember things, how you think about things, and how you make decisions. In short, it is clear that language and linguistic context have an effect on thinking. One version of this general claim is referred to as linguistic relativity, which suggests that our native language influences how we think and behave, and that there will be differences among groups of people as a function of their native language. That is, thinking is relative. This relativity depends in part on the native language a person learned to speak. The strongest form of this claim is often referred to as linguistic determinism and is also sometimes referred to as the Sapir-Whorf hypothesis, after Edward Sapir and his student Benjamin Whorf. This strong version of the hypothesis argues that language determines thought and can even place constraints on what a person can perceive. In general, both the strong version and the weak versions of this theory are widely attributed to Whorf, 1956, though he referred to his theory as linguistic relativity. Before he began the study of linguistics, Worf was a chemical engineer and worked as a fire prevention engineer. A possibly apocryphal story suggests that some of his ideas and interest in linguistics arose during the time when Worf was a fire prevention engineer and inspector. According to this story, he noticed employees smoking near canisters of gasoline, even though they claimed that the canisters were labeled as empty. An empty canister of gasoline can be very dangerous because of the fumes, but the workers labeled and conceptualized them as being empty. That is, they were linguistically empty, but not actually empty at all. Worf began to believe that one's native language determines what you can think about, and even your ability to perceive things. This story may or may not be accurate, but it still makes an interesting point about the difference between how one describes something linguistically and what that thing actually is. In other words, empty may not really be empty. Worf's bold claim. A famous quote reads, "We dissect nature along lines laid down by our native language. The categories and types that we isolate from the world of phenomena, we do not find there because they stare every observer in the face. On the contrary, the world is presented in a kaleidoscope flux of impressions which has to be organized by our minds, and this means largely by the linguistic systems of our minds. We cut nature up, organize it into concepts, and ascribe significances as we do, largely because we are parties to an agreement to organize it in this way, an agreement that holds throughout our speech community and is codified in the patterns of our language. All observers are not led by the same physical evidence to the same picture of the universe, unless their linguistic backgrounds are similar or can in some way be calibrated." Worf appears to be challenging Plato's notion of cutting nature at the joints, which was discussed in Chapter 4, meaning a natural way to divide the natural world in concepts. Rather, Worf suggests that concepts and categories are determined almost exclusively by one's native language. This is often thought of as the strongest form of linguistic relativity. In this case, the theory implies that one's native language necessarily determines thinking, cognition, and perception. Color recognition. However, this claim that language constrains or determines perception and cognition was a bold one, and in the middle of the 1900s was very provocative. Anthropologists, psychologists, and linguists began to look for and examine ways to test this idea. One of the earliest was a study by Berlin and Kay, 1969. They looked at the distribution of color terms across many different languages. They reasoned that if language constrains thought, then native languages may constrain the types of colors that can be perceived and used. In order to be considered, they looked at colors that were monolexemic, which means that the term had only one core meaning. For example, the word red is monolexemic because it has only a single core meaning, red. The term reddish is not monolexemic because there are two core units of meaning, red and the modifier ish. A basic color term cannot be included in the description of any other color terms. For example, indigo is not a basic term as it is a kind of blue color. Basic color terms cannot be restricted to a narrow class of objects. For example, the color blonde works for hair, wood, and beer, but not for many other things. Basic color terms must have a domain general utility in the language. A basic color term refers to a property that can be extended to objects in many different classes. What Berlin and Kay found is shown in Figure 5.2. All languages contain terms for dark and light. Red is also fairly common, and in languages with only 3 terms, those languages always have a word for black, white, and red. Red is a very salient color for humans, as it is the color of hot things and blood. As languages evolve, more terms may be added, but they still keep the terms from earlier stages. Figure 5.2, the evolution of color terms. Stage 1, dark, cool, and light, warm. Stage 2, red. Stage 3, either green or yellow. Stage 4, both green and yellow. Stage 5, blue. Stage 6, brown. Stage 7, purple, pink, orange, or gray. Berlin and Kay's work does not really argue completely against the linguistic determinism hypothesis, and their initial claims have been softened and criticized, but their work has provided a very interesting way to test it. If there are languages with only 2 or 3 words for colors, and if the linguistic relativity theory is correct, then speakers of that language should have difficulty categorizing colors with the same color name. Eleanor Roche, 1972, carried out a test like this with an indigenous group in Papua New Guinea. The Dani people have only 2 words to denote colors, and thus to linguistically define color categories. One category is called Milli and refers to cool, dark shades, such as the English colors blue, green, and black. The second category is Mola, which refers to warmer or lighter colors, such as the English colors red, yellow, and white. In several experiments, Roche asked her subjects to engage in color learning tasks with color cards. These cards, known as color chips, were taken from the Munsell color system, which is a system of describing color on 3 dimensions of hue, value, lightness, and chroma, color purity. The Munsell system has been used since the 1930s as a standardized color language for scientists, designers, and artists. The color chips are small cards with a uniform color on one side, usually with a matte finish. These look a lot like what you might find at a store that sells paint. One of the tasks Roche used was a paired associate learning task. A paired associate task is when participants are asked to learn a list of things, and each thing is paired with something they already know. So if you were asked to learn a list of new words in a paired associate task, each word would be paired with a word you already know. The word you already know serves as a memory cue. In Roche's task, the things to be learned were the Munsell color chips. Some of these color chips were what are referred to as focal colors. In other words, these color chips were at the perceptual center of their category. They were selected as the best example of a color category in the prior study with English speakers. When asked to pick the best example, Roche found widespread agreement for colors with the highest saturation. Thus, the focal color for red was the single chip that would be identified by most speakers of English as being the best example of red. Other chips might also be called red, but were not identified as the center of the category or the best example. And still other chips might be more ambiguous. They might be named red some of the time, and at other times might appear to be another color. You can pick out focal colors yourself. If you go to select a new color for text in your word processing program, you can see a wide arrangement of colors, but one seems to stick out as the best example of red, the best example of blue, the best example of green, etc. In other words, we would all probably agree which exact shade is the best example of the color green. This would be the focal color for green. In one of Roche's experiments, subjects were shown a chip and taught a new name. This was done for 16 color word pairs. Roche reasoned that English speakers would have no difficulty learning a paired associate for a focal color because it would already activate the prototype for an existing color category. They should perform less well on paired associate learning for non-focal colors because they would not have a linguistic label to hang on that color. Speakers of the Dani language should behave similarly, except they should show no advantage for most of the focal colors. That is because, if linguistic determinism is operating, the so-called focal colors would not be special in any way because speakers of the Dani language do not have the same categories. As far as linguistic determinism is concerned, they should not have the same focal colors as English speakers because they have different color categories. Our focal colors are the center of our color categories. Being shown a focal red should not activate an existing linguistic category for speakers of the Dani language, and so they should show little difference between learning the paired associates for focal colors and learning the paired associates for non-focal colors. This is not what Roche found, however. Speakers of the Dani language showed the same advantage for learning focal colors over non-focal colors that English speakers showed. This suggests that even though their language has only 2 words to denote color categories, they can perceive the same differences in colors as English speakers can. Thus, this appears to be evidence against a strong interpretation of linguistic relativity. The Dani language was not constraining the perception of its speakers. In many ways, this should not be surprising because color vision is carried out computationally at the biological level. Regardless of linguistically defined categories, we all still have the same visual system, with a retina filled with photoreceptors that are sensitive to different wavelengths. Naming common objects. More recent work has continued to cast doubt on the linguistic determinism theory. Barbara Malt's research, 1999, looked at artifacts and manufactured objects and the linguistic differences between English and Spanish. Participants in the experiment were shown many different common objects, such as bottles, containers, jugs, and jars. For speakers of North American English, a jug is typically used to contain liquid, is about 4 liters in volume, and has a handle. A bottle is typically smaller, has a longer neck, and no handle. A jar is typically made out of glass and has a wide mouth. A container is usually not made of glass, but of plastic. Containers come in round and square shapes and are usually used to contain non-liquid products. Speakers of English may vary in terms of the exact category boundaries, but most will agree on what to call a bottle, what to call a jug, etc. Whereas speakers of North American English refer to jugs separately from jars, speakers of Spanish typically label all of these things with a single term. In other words, a glass bottle, a jug, and a jar may all be labeled with the term frasco. If linguistic determinism held true for manufactured objects, Spanish speakers should show less ability to classify them into different categories based on surface similarity. In other words, if you speak a language that has only one term for all of these objects, you should minimize attention to the individuating features and instead tend to classify them as members of the same group. However, Malt's results did not support this prediction. English-speaking and Spanish-speaking subjects did not differ much from each other when classifying these containers via overall similarity. That is, they might have the same label for all of the different objects, but when asked to sort them into groups based on similarity, they all sorted them in roughly the same way as English-speaking subjects. The linguistic label did not interfere with their ability to perceive and process surface features. In short, these results do not support the strong version of the linguistic determinism theory. Count versus mass nouns. Despite the failings of the linguistic determinism theory, we have already shown that language can affect memory and cognition. Language also affects perception and interpretation in some cases. For example, consider the distinction between objects and substances. In English, as in many languages, we have nouns to refer to objects and nouns to refer to collections of things or substances. So-called count nouns refer to entities, objects, and kinds. We can say 1 horse, 2 horses, 5 cats, and 13 cakes. On the other hand, mass nouns typically denote entities that are not considered individually. In other words, a substance rather than an object. We might say a pile of leaves, a dash of salt, or a lot of mud. Even though the substance denoted by the mass noun might be made of individual objects, we are not referring to the individual objects with the mass noun. Rather, we are referring to the collection of them as a thing. A study by Soja et al., 1991, looked at when we acquire the ability to tell the difference between objects and substances. Do children learn to do this through exposure to their native language? The researchers examined English-speaking 2-year-olds. The children were shown objects that were given an arbitrary name. Then they were asked to pick out similar objects to the one they had just been shown and given a name for. For example, children might be shown a solid object or a non-solid object and told, "This is my blanket," or "Do you see this blanket?" The children were then asked to extend the concept by being asked, "Show me some more." In extending these words to new displays, 2-year-olds showed a distinction between object and substance. When the sample was a hard-edged, solid object, they extended the new word to all objects of the same shape, even when made of a different material. When the sample was a non-solid substance, they extended the word to other shaped puddles of that same substance, but not to shaped matches made of different materials. This suggests that the distinction may be acquired via language because both the object and the term were new. Even 2-year-old children are able to generalize according to linguistic information. Linguistic differences in time perception. A final example of how language affects the thinking process is demonstrated in a study by Lyra Bodinsky, 2001. She noted that across different languages and cultures, there are differences in the metaphors that people use to talk about time. This is related to Lakoff's ideas on conceptual metaphors, discussed earlier. English speakers often talk about time as if it is horizontal. That is, a horizontal metaphor would result in statements like pushing back the deadline or moving a meeting forward. Mandarin speakers, on the other hand, often talk about time as if it is on a vertical axis. That is, they may use the Mandarin equivalents of up and down to refer to the order of events, weeks, and months. It should be noted that this is not entirely uncommon in English, especially when considering time on a vertically oriented calendar. In fact, when I look at the Google Calendar on my smartphone, it is arranged in a vertical axis with the beginning of the day at the top and the end of the day at the bottom. Although I still use terms like "I've been falling behind on this project," I am also pretty used to thinking about time in the vertical dimension. We also have English vertical time metaphors, such as doing something at the top of the day. Exceptions aside, these metaphors seem to be linguistically and culturally entrenched in the idioms and statements that are produced. In order to test if the conceptual metaphor and language affect subjects' ability to understand the scene, subjects were first shown a prime to orient them to the horizontal or vertical dimension. They were then asked to either confirm or disconfirm temporal propositions. Figure 5.3 shows an example of a prime. In the first, an English example of a horizontal prime is shown. The black ball is ahead of the white ball. The second shows an English example of a vertical prime. The black ball is on top of the white ball. Boroditsky reasoned that if a prime activated a vertical metaphor and you spoke a language that encouraged thinking about time in a vertical dimension, you should see a processing facilitation. That is, you would be faster at judging the temporal proposition. If you saw a prime that activated the vertical metaphor, but you spoke a language that encouraged thinking about time in a horizontal dimension, then you should see a cost and would be slower at judging the temporal proposition. Figure 5.3. This is an example of a horizontal visual prime on the left. The black ball is ahead of the white ball. And a vertical visual prime on the right. The black ball is on top of the white ball. If subjects are shown one or the other prime before making a temporal inference, it can facilitate or interfere with the inference depending on how the speaker conceptualizes time. This is what Boroditsky found. After seeing a vertically oriented prime, Mandarin speakers were faster to confirm or disconfirm temporal propositions compared to when they had seen the horizontal prime. She found the reverse effect for English speakers. This suggests that language differences may predict aspects of temporal reasoning by speakers. Subsequent studies showed that this default orientation can be overridden. For example, Boroditsky trained English-speaking subjects to think about time vertically, giving them examples of vertical metaphors. In this case, after the training, the English speakers exhibited the vertical rather than the former horizontal priming effect. Although this study shows a clear impact of language on thought, it is not strong evidence for linguistic determinism because the native language does not seem to determine how time is perceived. Instead, local effects of linguistic context appear to be doing most of the work. Summary. Although many different species communicate with each other, only humans have developed an expansive, productive, and flexible natural language. And because language provides the primary point of access to our own thoughts, language and thinking seem completely intertwined. In Chapter 3, I argued that memory is flexible and malleable. This flexibility can occasionally be a liability, as memories are not always accurate. Memories are a direct reflection of the linguistic processes used during the encoding process and the retrieval process. This point was demonstrated in the discussion of eyewitness testimony and how the language used during questioning can change the content of the memory itself. In other words, memory for events is created by and affected by the language we use when describing the event to ourselves and to others. In Chapter 4 on concepts and categories, I suggested that concepts might be represented by definitions, lists of features, or centralized prototypes. Although each of these theories makes different claims about what is represented, all of them assume that a category and a concept have a label. That label is linguistic. Although the present chapter makes it clear that our concepts are not exclusively defined by a language, categories' verbal labels still provide an important access point. We access categorical information in many ways by using the linguistic label. In Section 2, we will examine the role of language in reasoning. In deductive logic, language use must be precise in order to determine a valid argument from an invalid argument. We will also look at the role of language in mediating between the faster, instinct-based behaviors produced by System 1 thinking and the behavioral outcomes produced by the slower, more deliberative System 2 thinking. Linguistic ability helps to mediate between these two systems. Furthermore, System 2 is generally thought to be language-based. In Chapter 9 and Section 3, language use can influence how decisions are made by providing a context or frame. The same decision can be framed as beneficial or as a potential loss. In other words, linguistic content and semantics can have a sizable impact on the behavioral outcome of decisions.